Eighth graders, this is to help you with question 7 on CR number 5. It says the number of visitors to the Canadian National Exhibition in 1998 was 2.045317 times 10 to the 6th. The number of visitors to the Pacific National Exhibition was 1,558,231 people. All right. Which exhibition had more visitors? Okay, so what they want you to do is they want you to know if you're comparing a number that's written in scientific notation and a number that's written in standard form, you have to put them both in the same form before we can compare them. Because we're talking about people, I'm going to write them in standard form for right now. So I need to take this number in scientific notation, 2.045317, times 10 to the 6th, and I need to write it in standard form. So it's given in scientific notation. I'm going to put it in what's called standard form. It means I'm just going to write it like a regular old number that we'd see anywhere. All right, so I have to take this decimal point. This is going to be a big, huge number, so I'm going to move it 6 places to the right. 1, 2, 3, 4, 5, 6. All right. So we don't want to have a bunch of decimal points running around in our number. We know our new location of our decimal point is right there. So we get 045,317. 1, 2, 3, comma, 1, 2, 3, comma. All right, so to the Canadian National Exhibition. So this is for the Canadian one. There was 2,045,317 visitors. To the Pacific, because now that they're both in standard form, we can now compare them. There was 1,558,231 visitors. So which exhibition had more visitors? The Canadian. 2 million is bigger than 1 million. So that would be the Canadian National Exhibition had more visitors. 2 million is bigger than 1 million. How many more visitors? Okay, so now we're going to subtract these values. So I lined my place values up, my ones place lined up, my tens, my 100, 1,000, so on. So you just got to make sure you line up your place values when you subtract. And that'll tell me how many more. When they're asking how many more, I know it's a subtraction problem. 7 minus 1 is 6. I can't take 3 from 1. Borrow from that 3 becomes a 2. That becomes an 11. 11 minus 3 is 8. 2 minus 2 is 0. 5 minus 8, can't take 8 from 5. Borrow from the 4. The 4 becomes a 3. There we have a 15. 15 minus 8 is 7. Can't take 5 from 3. Here, this is a 0, so I got to jump over here. Borrow from that 2. That 2 becomes a 1. That would become a 10. Now I can borrow from this. That 10 becomes a 9 to make this a 13. 13 minus 5 is 8. 9 minus 5 is 4. And then 1 minus 1 is 0. So how many more visitors? 487,086 more visitors. Now they want you to express this answer back in scientific notation. Okay, scientific notation, I know the form for that. The first number has to be between 1 and 10. So it has to be greater than 1, less than 10. The second factor will be some power of 10. So that's how I always set it up. If I'm doing scientific notation, I'm like, okay, my first number has to be greater than 1, less than 10. My second factor here has to be a power of 10. Because this is a big, huge number, I know it's going to be a positive exponent. So I have to locate my decimal point right here. 4.87086 is a number between 1 and 10. It's an ugly number between 1 and 10, but it's a number between 1 and 10. 4.87086 would be my first factor, because the first factor has to be greater than 1, less than 10. I'm just going to write it over here, 87086, because now I have to figure out my power on 10. It's going to be a big, huge number, so it's going to be a positive exponent. And what will that exponent be? 1, 2, 3, 4, 5. So that I had to move it over 5 places. So the exponent on that will be a 5. 1, 2, 3, 4, 5. Yep, to locate my exponent. So that would be that number in scientific notation. All right, I hope that helped.